So in the previous class, we learnt about the basics, that is how electricity is produced and what are the basic components of electric circuit. So now we will draw a small circuit diagram. Okay. So that is simple, that is given in page number 94. Chapter electricity, and in page number 94 they gave a circuit diagram, so that one bulb is present. So this is a symbol to represent bulb. Then one ammeter is present, so plus minus. Then here, so combination of cells, that is battery is present, and plug key and this closed. Okay, this is bulb, and this is ammeter, so I will represent that with the help of capital letter A. Then this is battery, so I will write BA. So the longer one having positive sign, and for the short one it is negative. Again positive, negative, and this is plug key. Plug key, and this is bulb. Now we have to represent the direction for it. We have to mention the direction, how electricity is flowing in this circuit. So generally we know that water flows from height, if we consider 2 beakers, and both are having small slit in that, and if we connect these slits, then what happens? The water in the higher region comes to lower region, and similarly wind blows from higher concentration area to lower concentration area. Similarly, when we consider osmosis process, in that also molecules move from higher concentration to lower concentration. Now here in this also, one terminal is having positive sign and the terminal is having negative sign. So when we take that positive and negative in the mathematical steps, so positive value is having greater magnitude and negative is having less. So similarly in this, so based on that all procedures, so in this case also we have to represent the direction of electricity must move from higher concentration to lower concentration. That is from positive, it is moving towards negative direction. Okay, from positive to moving towards the negative direction. But here the electrons in the circuit, okay, these are the wires, and electrons in the circuit, that means valence electrons in the circuit, move from negative direction to positive direction, but the electricity moves from positive direction to negative direction. So that is a conventional process. So in all the theories, so it is applicable, and so the diagram is very, very important for 2 marks. That is a simple circuit, a schematic diagram of an electric circuit consisting cell, electric bulb, ammeter, and plug. And after that they give a problem, that is example 12.1. So this is a very important diagram. So it shows the bulb, then the battery and plug key closed. Okay, for a complete circuit, so the plug key must be closed. For example, if you consider another diagram, so this is positive, negative, this ammeter, and here if you want to represent battery, it is positive, negative, positive, negative. So I will represent that with the help of battery, and this is key, then ammeter, then this is bulb. So here, tell me the electricity will flow from positive to negative or negative to positive. Fast, comment fast. In the second diagram, the electricity will move from positive to negative or negative to positive. So in this case, the key is open. So that's why it is called as open circuit. Okay, it is open circuit, and the first diagram is closed circuit because circle. So that's why it becomes complete circuit. When it becomes complete circuit, then electricity will flow in this circuit. And here in the second case, the plug is, the key is not inserted. So this dot represent key is inserted in that junction. But in this junction, key is not inserted. So that means key is open here. Okay, key is open here. Or we can consider key is open. So in this, the connection is not completed, or the circuit is not completed. That's why. Okay. So then, based on that, we have a problem, that is a current of example 12.1. So I will solve that. Very simple problem. So that is based on the production of electricity. So today we learned about electricity. I is equals to Q divided by T. So that is current in the circuit is rate of change of charges flowing in a particular direction. So rate of flow. Okay, that's why we are not using the time. So rate of flow of electric charge in a particular direction. So that comes to the electricity. Okay. So a current of 0.5 here. A current of 5 ampere. So here ampere. If you want to write in wordings, then you have used AMPER. But if you want for the abbreviation, that is or short form, then you have used capital A. Current of 0.5. This 0.5 ampere is drawn by a filament. So I will write only the data. Is drawn by a filament of an electric bulb for 10 minutes. In an electric bulb for 10 minutes. Okay, I will write full, otherwise you consider that as an meter. Okay, 10 minutes. Find the amount of electric charge. Find the amount of electric charge flows through the circuit. Electric charge flows. Just read the question. So here a current of 0.5 ampere. Current of 0.5 ampere. In an electric bulb, it flows in an electric bulb for 10 minutes. Find the amount of electric charge. First, while solving any problems in mathematics as well as in physics or in chemistry, in so first we are trying to given data, because it contains nearly half, or sometimes if the problem is very lengthy, then it contains nearly 1 mark. So that's why we will write the given data. So current of 0.5. So that means first what is the given value? Current, that is I is equals to 0.5. So why I use I here? Because I is the symbol used to represent the current. And in the formula we are not writing CURRE. Directly we are using capital I. So that's why we have to take that I here. So it represents the current, that is 0.5 here. And time is given. Time, that is t is equals to how much? It is 10 minutes. So I will not solve this, you have to solve. So you have the formula in front of you. I is equals to Q divided by T. So this is the formula. So we have to rearrange this and you have to utilize the values in that. Just comment me what is the value of Q. What is the value of Q first? So if not, I will do the next step. So when we do cross multiplication, it becomes Q equals to I into T. Q equals to I into T. So cross multiplication, because we are divided by 1 is present. 1 into Q, that is Q, and I into P, that is I. So now we have the current I and time T. Now comment me what is the value of Q. So fast. What is the value of Q? Okay, many are giving answers. So now I will solve this. So we know that charge, okay, charge, that is Q equals to I into T. I into this current into time. Current value is Q equals to 0.5 into time. So time is 10 minutes, but that is not SI. Okay. First thing, while solving the problems, first we have to write the given data. After that, you have to consider all the data in SI units. All the data in SI units. Q by T, Q is SI unit of charge is coulomb and SI unit of time is second. Coulomb per second is ampere. Correct? That is the SI unit of current. Ampere equals to coulomb per second. But if here we choose time in minutes, then what happens? Coulomb per minutes, but that is not equals to ampere. So first thing, we have to convert all the data into SI units. After that, we have to do the multiplication and we have to write the standard form of the formula and we have to write the SI units for the final answer. So that's why, so this is not 10 minutes, 10 minutes. For 1 minute, how many seconds? 60 seconds. Okay, for 1 minute, 60 seconds. For 10 minutes, 10 into 60. So it becomes how much? 600 seconds. So now what it becomes? 0.5. And time is how much? 600. So that's why Q becomes. So 0.5 that is same as 1 divided by 2. Okay, no need to multiply 0.5 to 600. So directly you can write this as 600 and 0.5 that is written as half. So 2 on the 2, 3 are 6, double 3. So it becomes directly 300. And SI unit of charge we have to write. So SI unit of charge is in chapter 6. Okay, just look at the steps. So if you understood this, just click on the like button. First, so what you have to do? First step, you have to write the given data. After that, you have to convert all the terms in SI units. After that, in the formula, we have to substitute the values and we have to write the SI unit. Okay. The next one. So next is very, very important, that is Ohm's law. So before going to Ohm's law, first we will learn about the potential difference. Okay. So we have potential difference as well as electric potential. So we will learn that electric potential afterwards. First we learned about the potential difference. Or see here in this potential difference, if you consider point A and point B, so electrons, for example, some electrons are present in point A and some electrons are present in point B. And now you have to tell what is meant by potential difference. So here potential difference, okay. First term is potential difference. So I consider 2 points, that is point A and point B, and now in point A there are some electrons, that means there are some free electrons, and in point B there are some free electrons, and I want to move a single electron from one point to another. Okay, I want to move one electron from one point to another. That means I am considering point A and one electron from point A, and I will take that to point B. So now what is meant by potential difference? So the work done to move a unit charge means single charge, work done to move a unit charge from one point to another. So that is given in so one point is given: the flow of charge contained to metal wire, the gravity of force has no role to play. The electron move only if there is a difference of electric pressure. So that means here also the electrons will move from higher pressure to lower pressure. So therefore the potential difference means here the work done to move a unit charge is single charge from one point to another. How much work done is done to move that charge. So because if you consider a big stone, and if you want to move this, so what we have to do? We have to put pressure on it. So when you put pressure on that, so it will move. So that movement is nothing but a work done. How much work done? That is equals to how much stone is moved from its original point. So if you consider O is the original point, after that it comes to point B. So this is the work done. OB is the work done. So how much amount of force we have to apply to move this stone from one point to another. So that is here work done. Similarly here, how much amount of work done is done to move a unit charge from one point to another. So then after that we have another term, that is electric potential. Electric potential. So in this case, if you want to move or a work done to move a unit charge from infinity to a particular point. So if you consider a particular point A and some electrons are present at infinity, so here we have to assume something. So how much work done we have to do to move unit charge from infinity to a particular point. So that amount of work here is known as the electric potential. Okay. Or simply we can consider the potential difference. So that is amount of work done to move unit charge from one point to another. Amount of work done to move unit charge from one point to another point. So based on that we have one formula here. So in page number 95 again we define the electric potential difference between 2 points in an electric circuit carrying some electric current as the work done to move unit charge from one point to another. So that is for the potential difference. And for electric potential, the amount of work done to move unit charge from infinity to a particular. So based on that they give one formula, it's potential difference between the 2 points, that is equals to work done divided by charge. So that is potential difference that is equals to work done divided by charge. Work done divided by charge. So now we will come to the SI. So here potential difference, that is equals to work done divided by charge. That means how much amount of work is done to move a unit charge from one point to another point. So when you consider potential difference, the SI unit of potential difference, SI unit of potential difference. SI the potential difference, that is volt, small volt or capital. So just note down that or mark that point in the textbook. So the SI unit of potential difference is volt, small volt, or you can write capital. So that is SI unit of potential difference. And next one is work done, and SI unit of charge is no, that is representative of letter Q, and the SI unit of charge is full. And this potential difference will denote with the help of V. Okay, potential difference will represent that with the help of letter V. And the next one is work done. The SI unit of work done that is joule, small j or capital, small joule or capital, that is the SI of work done. Okay, work done or work will represent that with the SI unit, that is joule. So here also all the letters are small g o u l e, or we will represent the help of capital letter J. The reason, because it is the name of a scientist. So based on this formula, we can write here the letter V, and work done with the letter W, and charge with the letter Q. So that's why we can represent after rearranging directly when we do the cross multiplication, it becomes W equals to V into. So this two formulas are also important. That is this W equals to V into, that is after rearranging the first expression we will get that. And here the potential difference, that is equals to work done divided by charge. Okay, that is joule per coulomb, because SI unit of work done is joule and SI unit of charge is coulomb. Therefore, the volt, that is equals to joule per coulomb. Now you have to tell me what is meant by 1 volt potential difference. What is meant by 1 volt? First, just like we wrote the definition for an ampere yesterday. 1 ampere is meant by 1 ampere. So similarly, in this case, we have to tell what is meant by 1 volt of potential difference. So define 1 volt. Define 1. Just comment me by using the expression. We know the expression is V is equals to W divided by Q. Now what is meant by 1 volt potential difference? So this 1 volt will represent the help of 1. So that is possible when 1 joule and 1 coulomb. So V is not volt here, V is not potential difference, V is volt here. Okay, and 1 volt, that is equals to SI unit of work is joule. Similarly, SI unit of charge is C, that is coulomb, and SI unit of potential difference, that is V. So now 1 volt means 1 joule per 1 second. 1 joule per 1 second. write that, or we have to frame one definition for it. What is meant by 1 volt of potential difference? So 1 volt of potential difference is when 1 joule of work done is done to move a unit charge, single charge we have to move, and to move that single charge, how much amount of work we have to do? That is 1 joule of work. Okay, so therefore when potential difference is 1 volt, when and only when 1 joule of work done is done to move a unit charge from one point to another point. So I will write the definition. Potential difference is 1 volt when 1 joule of when 1 joule of work done to move a unit charge, work done to move a unit charge from one point to another, from one point to another. So potential difference is 1 volt when 1 joule of work done to move a unit charge from one point to another point. Unit charge from one point to another. Just look at the definition. So based on that, we will solve a problem. That is example 12.2. How much work is done? How much work is done in moving a charge of 2 coulomb across 2 points, having the potential difference having a potential difference having a potential difference 12 volt. So first we will write the given data. So that is potential difference that is V equals to 12 volt. So this V is different, that V is different. So this is used to represent potential difference and this is used to represent the volt. Then charge. Okay, charge is given, comma Q, that is equals to Q coulomb. Now just read that question once again. So how much work is done in moving a charge of 2 coulomb across 2 points having a potential difference 12 volt. So for the potential difference, that is 12 volt and charge is 2 coulomb. Now we will write that is work done, that is W, that is equals to V into Q. So because we know that V is equals to W divided by Q, that means W equals to V into Q. And potential difference how much? 12 into charge is how much? Now comment me the answer with SI first. Comment me the answer with SI. What is the work done here to move that 2 coulomb charge from between the potential difference to value? First, how much amount of work is done here? That is W, that is work done equals to 2 into the 24, and SI of work is 0. So I will write it with the help of capital H. So here, how much work done they asked, and they gave a charge that is 2 coulomb and potential difference they gave that is 12 volt. So therefore we will write the given data first, that is potential difference V is equals to 12 volt, then charge is 2 coulomb, and the work done that is W is equals to V into Q, that is 12 into, and that is the job is the SI of work done. That's what we are right. So if you understood this, just click on the like button. And so here in this class we learnt about the potential difference and electric potential. That is, potential difference means the amount of work done to move a unit charge from one point to another point, and electric potential means the amount of work done to move a unit charge from infinity to a particular point. So apart from that, we learnt about this expression, that is potential difference, that is equals to work done divided by charge. In other words, if you want to represent 1 volt, then the potential difference is said to be 1 volt when and only the 1 joule of work is done to move a unit charge from one point to another point. Okay, I will continue in the next class. Thank you.